So looking at the general form of an equation for a circle, we have 0 equals x squared plus y squared plus dx plus ey plus f. So we do have these three coefficients that we don't know, so therefore we would need 3 points to find 3 unknowns. And we're going to go ahead and substitute those into this equation. So we have 0 equals 0 squared plus 0 squared plus d times 0 and e times 0 plus f. And that's using the point 0, 0. Now if we use our next point 0, 5, then we're going to have 5 equals 0 squared plus 5 squared. So d times 0, e times 5 plus f. And then the last point we're given is 3, 3. So that's going to be 3 equals 3 squared plus 3 squared. Oh my gosh, I did this totally wrong. I'm so sorry. This is not y equals. These are 0 equals. So these should actually be 0 equals. That's a constant in the equation. So now we're going to substitute for the x. We're going to put in a 3. And then for the y, we're also going to put in a 3. So now we can take these equations and rewrite them so that we are simplifying it. 0 plus 0, 0. And then we have 0d, 0e, and 1f. Then we have 0 equals 25 plus 0d and 5e and 1f. And the last one is going to be 18 plus 3d plus 3e plus 1f. All right, so that's all looking good. But now what we want to do is we want to rewrite this one more time so that it'll be ready to be transferred into a matrix. So I'm going to put the coefficients and the variables at the beginning. And then I'm going to move this constant to the other side by using the inverse operation. So in this case, it's still equal to 0. Over here we have 0d plus 5e, 1f equaling negative 25. We're basically employing the commutative property, moving things around. It's all good. Negative 18. Now I can write all of this as a beautiful matrix equation. Well, we have our 3 by 3 coefficient matrix. The variable matrix. And then it's going to be equal to our answers result matrix. So this is basically matrix A. This is matrix X. And this is going to be matrix B. And we know from matrix equations and solving matrix equations that in order to solve for matrix X, we're basically going to multiply the inverse of matrix A times matrix B. And so let's use a calculator for that. So I'm going to go ahead and clear out my calculator. Second plus, sorry, I'm using the left hand and that is not good for me. Second plus 712. All right. Now we're going to go into our matrix and we're going to edit. The first matrix, matrix A, is going to be a 3 by 3. And we had 0, 0, 1. And then 0, 5, 1. And 3, 3, 1. Second quit. And put our matrix in again, and this time we're going to edit matrix B, which is a 3 by 1. And that was 0, negative 25, negative 18. And now we're going to second quit so we can actually do the math. So to find matrix X, we're going to do matrix A inverse. Uh-oh, not squared. Go back. Let's just try that again. Matrix A inverse times matrix B. And we have that D equals -1, E equals -5, and F equals 0. So let's go back and write that out. So matrix D, E, F is going to be -1, -5, and 0. So when we write general form of this equation, we have 0 equals x squared plus y squared plus dx plus ex plus ey, sorry, plus f. So we're going to have plus -1x plus -5y plus f. Clean that up, make it look nice. That is x squared plus y squared minus x minus 5y, because that's a 0. And that is all.